The days of only one significant space station in low Earth orbit have come to an end as the Tiangong space station joins the International Space Station. The newcomer on the block features quite a few differences as well as similarities to the station that has been orbiting the Earth for decades now, something that is important for future space infrastructure and various missions. For many years now, United States rules have prohibited NASA from engaging in bilateral partnerships with China. This had an effect on the relationships and partnerships relating to the ISS. Not too long ago, however, China began launching its own modules to create its own station. This new space destination features a more modern design and a smaller footprint. The station is China's first long-term space station, part of the Tiangong program and the core of the third step of the China Manned Space program. The initial target configuration for the end of 2022 consists of 3 modules, which may be expanded to 6 in the future. Here I'll go more in depth into these 2 stations, how exactly they compare, what to expect in the future, and more. According to the CMSA, which operates the space station, the purpose and mission of Tiangong is to develop and gain experience in spacecraft rendezvous technology, permanent human operations in orbit, long-term autonomous spaceflight of the space station, regenerative life support technology, and autonomous cargo and fuel supply technology. It will also serve as the platform for the next-generation orbit transportation vehicles, scientific and practical applications at large scale in orbit, and technology for future deep space exploration. Currently, the station consists of 3 primary modules. The core cabin module was the first primary structure launched in April 2021. It provides life support and living quarters for 3 crew members and provides guidance, navigation, and orientation control for the station. The module also provides the station's power, propulsion, and life support systems. The module consists of 3 sections: living quarters, a service section, and a docking hub. The living quarters will contain a kitchen and toilet, fire control equipment, atmospheric processing and control equipment, computers, scientific apparatus, communications equipment to send and receive communications via ground control in Beijing, and other equipment. You then have the first of the 2 side modules, Wintian, which lifted off in July of last year. This module provides additional avionics, propulsion, and life support systems as backup functions for the main station. It's also fitted with an independent airlock cabin to serve as a main entry-exit point for extravehicular activities, or EVA. For the scientific payload, the LCM is equipped with multiple international science racks and 22 payload adapters on the exterior for various types of experiments. Aside from scientific equipment, the module features 3 additional living quarters designed for short-term stay, which will be used during crew rotation. The second side module, Mingtian, was launched on the 31st of October 2022. This module is equipped with extended in-orbit experiment capacity. Similar to the other modules, it's divided into multiple sections, including the pressurized crew working compartment, the unpressurized cargo section, the cargo airlock/on-orbit release mechanism, as well as the control module section featuring external experiment adapters, a communication antenna, and 2 solar arrays. In total, it carries 13 experimental racks and 37 external payload adapters. The cargo airlock is specifically designed for conveying payloads from inside the station to the exterior. Electrical power is provided by 2 steerable solar power arrays on each module, which use cells to convert sunlight into electricity. Energy is stored to power the station when it passes into the Earth's shadow. Resupply spacecraft will replenish fuel for the station's propulsion engines for station keeping, to counter the effects of atmospheric drag. The solar arrays are designed to last up to 15 years. In accordance to the plan, by the end of 2022, the fully assembled station had 3 22 metric ton modules in a basic T-shape. With the modular design, the space station can be further expanded into 6 modules, enabling more astronaut participation in the future. Now that we know more about the Tiangong station and its recent additions, we can take a closer look at how it compares to the International Space Station. One of the main differences between the 2 stations is size. In total, the ISS is made up of 16 pressurized modules, most of which feature a common diameter of around 4.2 meters. The Tiangong, on the other hand, only has 3 main modules that share the same diameter of 4.2 meters as well. This being said, the Chinese station has a much more modern interior, with less electronics and various instruments in view. Part of this can be attributed to the fact that the ISS is an aging station, with initial segments having launched in 1998. Although old, over time technology has been updated and is capable of completing the tasks at hand for astronauts in the station. In total, the Tiangong station is slightly over 1/3 the size of the International Space Station. This offers a decent amount of room for crew to live and work. On the ISS, double-sided solar arrays provide electrical power. These bifacial cells collect direct sunlight on one side and light reflected off from the Earth on the other, and are more efficient and operate at a lower temperature than single-sided cells commonly used on Earth. With its large size, however, the station's systems and experiments consume a large amount of electrical power, almost all of which is converted to heat. In order to keep the internal temperature within workable limits, a passive thermal control system, or PTCS, is made of external surface materials, insulation such as MLI, and heat pipes. If the thermal control system cannot keep up with the heat load, an external active thermal control system, or EATCS, maintains the temperature. This system consists of an internal, non-toxic water cooling loop used to cool and dehumidify the atmosphere, which transfers collected heat into an external liquid ammonia loop. From the heat exchangers, ammonia is pumped into external radiators that emit heat as infrared radiation, then back to the station. The EATCS provides cooling for all US pressurized modules, as well as the main power distribution electronics to the SO, S1, and P1 trusses. Not to mention, it can reject up to 70 kilowatts. This is much more than the 14 kilowatts of the early External Active Thermal Control System, or EEATCS, via the early ammonia servicer, which was launched on original missions. Moving on, the ISS is currently maintained in a nearly circular orbit with a minimum mean altitude of 370 kilometers or 230 miles, and a maximum of 460 kilometers or 290 miles in the center of the thermosphere, at an inclination of 51.6 degrees to Earth's equator. This orbit was selected because it is the lowest inclination that can be directly reached by Russian Soyuz and Progress spacecraft without overflying China or dropping spent rocket stages in inhabited areas. It travels at an average speed of 28,000 kilometers per hour or 17,000 miles per hour and completes 15.5 orbits per day or 93 minutes per orbit. The station's altitude was allowed to fall around the time of each NASA shuttle flight to permit heavier loads to be transferred to the station. After the retirement of the space shuttle, the nominal orbit of the space station was raised in altitude from about 350 kilometers to about 400 kilometers. Other, more frequent supply spacecraft do not require this adjustment as they are substantially higher performance vehicles. In comparison, the Tiangong features a typical orbit altitude of around 390 kilometers or 240 miles. The space station is fitted with conventional chemical propulsion and ion thrusters to adjust and maintain the station's orbit. 4 Hall effect thrusters are mounted on the hull of the Tianhe core module. Hall effect thrusters are created with manned mission safety in mind, with effort to prevent erosion and damage caused by accelerated ion particles. Lastly, you have the time left for each station. According to the Outer Space Treaty, the United States and Russia are legally responsible for all modules they have launched. Several possible disposal options were considered, including natural orbital decay with random reentry, boosting the station to a higher altitude, which would delay reentry, and a controlled targeted deorbit to a remote ocean area. In late 2010, the preferred plan was to use a slightly modified Progress spacecraft to deorbit the ISS. This plan was seen as the simplest, cheapest, and with the highest margin of safety. All this being said, currently, there are plans to keep the station and continue to use it up until around 2031. Not long ago, China launched 3 large modules to create the Tiangong station. Now there are 2 significant space stations in low Earth orbit, with the ISS continuing to operate. They feature some similarities and a lot of differences. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.